When developing software, it's essential to ensure that our code behaves as expected, under all circumstances. However, testing code that relies on external systems such as databases, network services, or hardware can be challenging. That's where dependency injection and mocking come into play. Dependency injection allows us to pass the components that a class relies on as parameters, rather than creating them internally. This design pattern not only improves modularity but also makes our code much easier to test. Mocking, on the other hand, is a technique that involves replacing real objects with simulated versions, or mocks, that mimic the behavior of the real dependencies. This means we can test a component in isolation, ensuring that its logic is sound, without being affected by external factors. At its core, dependency injection is about inverting the control of dependency creation. Instead of a class creating its own dependencies, it receives them from an external source. Imagine a simple example. You have a class that requires access to a data service. Without dependency injection, the class might create an instance of that service internally. This makes it difficult to test because you're forced to work with the actual data service, which might involve time-consuming operations like network calls or database queries. By using dependency injection, you instead provide the data service to the class from the outside, typically via a constructor, a property, or a setter method. This small change dramatically improves testability. In your tests, you can inject a fake or mock version of the data service, allowing you to simulate different scenarios quickly and reliably. Let's consider a practical scenario. Suppose you have a class called order processor that depends on an external payment gateway. In production, the payment gateway might connect to a real payment system. For testing, however, you can inject a mock payment gateway that simulates a successful transaction without incurring any real charges. This design allows you to focus solely on the logic within the order processor without worrying about the external system. There are several common approaches to dependency injection, each with its own benefits and use cases. Understanding these different types can help you choose the most appropriate method for your project. Constructor injection is the most widely used form of dependency injection. With this method, dependencies are provided as parameters to the class constructor. This approach ensures that a class cannot be instantiated without its required dependencies, promoting immutability and making dependencies explicit. In this example, the data provider is passed into the calculator through its constructor, ensuring that every calculator instance has the necessary dependency available. Setter injection involves providing dependencies through public setter methods after the object has been constructed. This approach is particularly useful when dependencies are optional or when you want to change dependencies during the lifetime of the object. Here's an example. Setter injection offers flexibility by allowing the dependency to be modified post-instantiation, though it does introduce the risk of the dependency not being set before the object is used. Method injection is another variant where dependencies are provided as parameters to the methods that require them, rather than being stored as fields in the object. This approach is particularly useful for one-off operations or when the dependency is only needed temporarily. With method injection, the data provider is supplied only when the calculate method is called. This makes the dependency explicit to the method, although it can lead to repeated passing of the same dependency if multiple methods require it. Interface injection is a less common form of dependency injection where the dependency is provided through an interface that the client must implement. The injection framework calls the method defined in the interface to inject the dependency. While powerful, it is often considered more complex and is less frequently used than the other types. Each of these methods has its advantages and trade-offs. Constructor injection is generally preferred for mandatory dependencies and ensuring immutability, whereas setter and method injection offer greater flexibility when dependencies are optional or when a dependency's state may change over time. Mocking is a powerful testing strategy. When we create a mock, we are essentially constructing a dummy implementation of a dependency that mimics its interface and expected behavior. This means that during testing, instead of interacting with the actual external dependency, our code interacts with the mock, which is both faster and easier to control. This gives several benefits. By replacing real dependencies with mocks, you isolate the unit of code under test. This ensures that if a test fails, you know it's due to an error in the unit itself, rather than an external component. Real external systems can be unpredictable. Network latencies, downtime, or varying responses can all affect the outcome of your tests. Mocks, however, provide predictable responses. You can predefine what the mock should return, ensuring consistent and repeatable tests. External systems are often slower than in-memory operations. By using mocks, you bypass these slower operations, making your test suite run faster. For instance, imagine you have a class called Weather Service that retrieves data from an online API. In your test environment, rather than calling the actual API, you would inject a mock version of the service. This mock could be programmed to return a specific weather condition, such as sunny, allowing you to verify that your class responds appropriately to that input. Let's look at a concrete example to tie these ideas together. Suppose we have a class that performs a calculation based on data provided by an external source. In production, this data might come from a live web service, but in our tests, we want to simulate this dependency. Here's a simplified example using constructor injection. In this case, calculator relies on a data provider to supply some numerical data. Instead of creating an instance of data provider within the calculator, we inject it through the constructor. This allows us to easily swap out the real data provider with a mock during testing. Now let's consider our test scenario. We can create a mock implementation of data provider that returns a known value. This example clearly demonstrates how dependency injection facilitates testing. Instead of relying on the real data provider, which could be slow, unreliable, or hard to control, we've injected a mock that provides a predictable outcome. This strategy not only simplifies our tests but also makes our production code more flexible and easier to maintain. It's important to acknowledge both the benefits and potential pitfalls of using dependency injection and mocking. Benefits include improved testability. By injecting dependencies, you create an environment where your units can be tested in isolation. This leads to more reliable and maintainable tests. Flexibility. Dependency injection allows you to change the behavior of your components by swapping out dependencies, making your code more adaptable to change. Enhanced modularity. When classes don't create their own dependencies, they become less tightly coupled. This modularity is a cornerstone of robust software design. However, there are some possible disadvantages. Excessive reliance on mocks can lead to tests that are tightly coupled to the implementation details of your code rather than its behavior. Always aim to test the public interface of your components. Keeping mocks in sync with the real dependencies can sometimes add extra maintenance overhead, especially if the external interfaces change frequently. While dependency injection and mocking simplify testing, they also introduce additional layers of abstraction. It's important to strike a balance between simplicity and testability. In summary, dependency injection and mocking are invaluable techniques in modern software development. They allow you to design flexible, decoupled systems where each component can be tested independently. By injecting dependencies from the outside, whether through the constructor, setters, methods, or even interfaces, you can easily replace real objects with mocks, leading to faster, more reliable unit tests. Throughout this video, we've explored the fundamentals of dependency injection, examined its different types, and seen how these techniques enable the substitution of real dependencies with mocks. The examples highlight how the techniques can be applied to produce more maintainable and testable code. Armed with these practical examples, you will be able to modularize your unit tests and approach complex code with confidence.